Have you ever wondered why some quadratic equations have two solutions, while others have only one or even none? Today, we will use a graphing calculator approach to visualize how the discriminant determines the number of real roots in any quadratic function. The key to understanding these roots lies within the quadratic formula. The expression under the radical, b squared minus for ac, is called the discriminant. This single value tells us the nature and number of the x-intercepts before we even begin graphing. When we graph a quadratic equation, the roots are the points where the parabola crosses the x-axis. By calculating the discriminant, we can predict exactly how many times the curve will touch or cross this horizontal line. In our first case, if the discriminant is greater than 0, the square root in our formula yields a positive value. This results in two distinct real roots, meaning the parabola must cross the x-axis at two different locations. If the discriminant equals exactly 0, the square root disappears. This leaves us with only one solution, known as a double root. Visually, the vertex of the parabola just kisses the x-axis without crossing through it. When the discriminant is less than 0, we cannot find a real square root for a negative number. Graphically, the parabola stays entirely above or below the x-axis, never touching it, resulting in no real solutions. Let's put this into practice using a graphing calculator. We start by entering our function into the y equals menu. This allows us to see the relationship between the algebraic coefficients and the physical shape of the curve. For the equation x squared minus for x plus 3, our discriminant is 4. Since 4 is positive, the calculator shows two clear intercepts. We can use the 0 to function on the calculator to confirm these roots are at x equals 1 and 3. Always identify your coefficients carefully. Here, a is 1, b is negative 4, and c is 3. Squaring negative 4 gives 16, and subtracting 12 leaves us with a positive 4, confirming our two-root prediction from the graph. Next, consider x squared minus 2x plus 1. The discriminant calculation results in 0. When we hit graph, the calculator displays a parabola that touches the x-axis at exactly one point, the vertex at x equals 1. A discriminant of 0 indicates a perfect square trinomial. On your calculator screen, you will see the curve approach the axis, touch it, and immediately turn back. This single point of contact represents our one real solution. Finally, let's look at x squared plus 2x plus 5. The discriminant is negative 16. The calculator shows the parabola is shifted upward, and there are no x-intercepts visible on the screen, confirming there are no real roots. When using a calculator, always ensure your window settings are wide enough to see the x-axis. If the discriminant is positive but you see no intercepts, you may need to zoom out to find where the curve crosses. To summarize, a positive discriminant means two real roots and two intercepts. A discriminant of 0 means one real root where the vertex touches the axis. A negative discriminant means no real roots and no intercepts. You can use the trace or value tools on your calculator to explore the graph. While the discriminant tells you how many roots exist, the graph helps you estimate their values visually before solving algebraically. Let's try a quick check. For the equation x squared plus 6x plus 9, calculate the discriminant. Since 6 squared is 36 and 4 times 1 times 9 is 36, the discriminant is 0. This means it has exactly one real root. Mastering the discriminant allows you to predict the behavior of quadratic equations instantly. By combining algebra with the visual power of a graphing calculator, you gain a deeper understanding of how equations translate into shapes. Generated by Vision Solve AI.